Hello and welcome. Today we're going to be talking about Venn diagrams. We're going to be arranging sets and subsets, etc. A Venn diagram is a visual way of representing the relationship between sets. Oftentimes we use a rectangle to represent the universal set, and each shape within the rectangle represents a subset of the universal set. So let's go ahead and construct a Venn diagram and look at what it might look like for two disjoint sets. The first thing we're going to do is make a rectangle. This rectangle represents the universe. In this case, it says, provide a possible description for each if the universal set contains all domestic pets. And so I'm going to put a little U up in the corner here. And now every possible domestic pet is here, all of them. And then what I'm going to do is it says two disjoint sets. So I'll put two circles here. And disjoint means not overlapping. There is no connection between them. So disjoint means no overlap, right? They're separate from each other. They're not intersecting at all. So if we call this one A and this one B, let's go ahead and give an example or a description of what these might be. So maybe I let A will be four-legged pets. Now, that's pretty broad. There's a lot of them. All of our cats and dogs and rats and all the four-legged pets, tortoises, these are all pets that I've had in my house within the last year, actually. But what if we let B be birds? I probably would have written parakeets, but I'm not good at spelling. So notice that there are no four-legged birds that I can think of. So if there are, I'm sorry. But in general, birds like parakeets especially, they would not overlap with the four-legged pets. Now, there are still other pets out there. There are some pets that are not birds and not four legs, and those would fit out here in the universe. Things like snakes, right? They're not four-legged and they're not birds. So those would be out here in the universe. But any four-legged pet would be here in A, and any bird would be over here in B, and there is no overlap. Let's go to the next one here. It says, this time we're going to show two nested sets. In other words, one is a proper subset of the other. So I'll put my circle here, and then a nested subset means that it's a smaller subset inside of that because it's proper. So it says the universal set is a set that contains all animals. Every animal possible would be here in the universe. You know, if we wanted to, we could again I'll call this one A and this one B. And we could then say that A is domestic pets. I know that might seem kind of boring since we just did it. There's a lot of different answers for this, and I would strongly encourage you to come up with your own and just see if you think they work or not. And then B might be dogs. So all the dogs, you know what? Actually, no, because there's gonna be some people out there that are like, oh no, coyotes are dogs. So how about let's back this up a little bit and we'll say golden retrievers. Golden retrievers, every golden retriever would be considered a domestic pet. And so if you're a golden retriever, you're probably not watching this, but if you're a golden retriever, you would be here inside of circle B. And notice that you would be also completely contained inside of circle A. So you are a domestic pet. But there are some other pets that are not golden retrievers that would be out here in A, but not in B. Okay, and that's why it makes this a proper subset or a nested set, because there are still some pets that are in that green section. All right, let's move on to the next one. The next one says, provide a possible description for each set if the universal set is all motorized vehicles, and we're to show two overlapping sets. So my universal set is all motorized vehicles. And we'll come over here and we'll call this one set A, And we'll put another one. Overlapping just means that there's some type of overlap. Here's set B. And this time, let's let A be Fords. Right, there's a pretty general term. And we'll let B be some subset of that. But maybe there's some other vehicles that aren't Fords. So I'm going to put electric vehicles or EVs. Now, when you think about this, there are some Fords that are not electric vehicles, and those would fit out here. A lot of the Ford vehicles are not electric vehicles, and those would fit out here. There are some Fords that are electric vehicles, like the Mustang EV or the Ford Lightning, where it's a Ford, but it's also an electric vehicle. And then there's some vehicles that are not Fords, but they are electric vehicles. So those would belong out here in that blue part. So for example, like Tesla Model 3 would be out there in the light blue section. So the green section represents vehicles that are both Ford and EVs. Okay. All right, let's go ahead and do some with some numbers involved. The first one says find A intersect B. This again means the overlap or the intersection. In English, we would also call this the word and. So A and B. We're looking for the numbers that are in both A and also in B. And hopefully you can just kind of look at this and see that it would be right in here. So this would be 16 and 15. Keep in mind that the order that you write them does not matter. Over here on number 5, it says A union B. This is the word or, A or B, right? This is, we could also read this as union. And it just means that you would bring them all together. So anything that's in A along with anything that's in B, anything that's circled, anything that's in those blue circles would be in A union B. And so that would be A, B, C, D, E, F, and that's it. Notice that these out here are not in A union B. Okay. In fact, what I could say A union B and put a bar over the top of it like this. This would be not A union B. And the answer to this one, by the way, would just be GH. Just a little extra practice with that, what that not is. So not A union B. What I would do is I would first figure out what A union B is, which you can see I already did. That would be all of this, and all of this is A union B. And if I want not that, then it means don't use that. Use everything else that you see other than those. And so one thing that I even like to do is sometimes I just like to cover it up completely when I see that word not. That way I don't accidentally use it. Now it's very easy for me to see what not A union B is because I found what A union B was, I covered it up or I got rid of it, and then that leaves me only left with that. And that's why not A union B is GH. Okay, I do want to reiterate that was not what this question was asking. I just know that sometimes those knots can be a little confusing. All right, let's look at identifying where all these numbers go, and then we can start to answer the rest of these questions. When we want to put these numbers into a Venn diagram, there's a few different ways that you can go about doing this. One would be to look at each individual number and just decide where it goes. So I could start with my universe and I could say, all right, 1, I see that that's also in set B, but not in A, so I'll put a 1 here. And then once I have that, I'll cross it out. 2, I can see that 2 is in A and B, so that's in the overlap, so I'd write it there. 3, I can see that 3 belongs in set B, so I'll write 3 over here. 4, of course, is in all of them, so I would write that in the overlap. 5 seems like it's only in set B, Now again, all of these are in the universe. So keep that in mind. I'm just going down the universe and making my way through there. 6. 6 is only in A. So I'll come write a 6 over here. 7. 7 doesn't belong in either A or B, but it's in the universe. So it's going to belong somewhere. I'll put it out here, outside of sets A and B, but still inside my universe. Remember, this is the universe here. So we've got 7. Next, I see that 8 seems to belong in set A. 9 belongs out in the universe because it's not in set A. And then 10 is also in set A. So that's one way to go about doing this. There are plenty of others. I might even look at these and say, I can see these are the even numbers, 2 through 10. These are the numbers 1, 2, 3, 4, 5. So I might think of this as like 1, 2, 3, 4, 5. And then when I see that A has a couple of those same numbers, 2, 4, 6, 8, and 10, I might look at this and say, well, I see that there's a 2 in both of them. So I should put the 2 there and erase them out here. Like that. There. I also see that there's a 4 in both of them. So I'll erase them there and put the 4 in the middle. And that looks like that's it. There's no more overlap. Then the next thing that I might do is go through and I see that I have a 1, a 2, a 3, a 4, a 5, a 6. I don't have a 7 anywhere, so I'll put the 7 on the outside. I have an 8. I don't have a 9, so I better write the 9 out there. And I have a 10. Okay, so there's plenty of ways to go about doing this. However you want to do it, that was 2 different ways. There's even others. Let's go ahead and answer some of these questions and get comfortable with some of our notation. When I have a complement, what I'm looking at here is all of the elements in A. This would be A, everything that's inside the circle. Everything that's outside the circle, that's a complement. A complement would be 1, 3, 5, 7, and 9. A is everything inside the circle, that's all these. A complement is everything outside the circle. So again, if you want to just cover these up so that you don't accidentally write them down, you can. There. Everything that you still see is a part of a complement, or in other words, not A. The next one, B complement. What I like to do is I'll circle B and say, well, B is everything inside the circle, so B complement is everything outside the circle. That would be 10, 6, 8, 7, 9. The order that you write these doesn't really matter. Every once in a while, you'll run across someone who says, no, they need to be written in ascending order. That's okay. If that's what they need, that's fine. But it really is just a list of numbers, and the order of that list doesn't truly matter. As a teacher, it's much easier for me to grade them when they're written in ascending order, but technically this is still correct. The next one I have is A intersect B. Remember, this intersect or overlap, right? That's also the and. So when I look at these, I'm looking for the overlap of A and B. Well, that overlap is this football shape right here. And that would just be 2 and 4. The next one is A union B. A union means to bring together. So anything that's in A along with anything that's in B, that would be A union B. So I can start out by writing everything that's in A. That's 10, 6, 8, 2, 4. And then I would write everything that's in B, but I'm not going to write those same numbers 2 and 4. I'm not going to write them again. I've already written them once. So I'm not going to write 2 and 4, but I will include 1, 3, 5. There we go. Now, I can look and notice that I have 1, 2, 3, 4, 5, 6, 7, 8 numbers here. And when I look over at my set, I have 1, 2, 3, 4, 5, 6, 7, 8 numbers in my Venn diagram that's inside the circles. That's how I know that I'm right. Just a quick little aside, if the question had instead said A union B with these vertical lines on the outside, that's asking for the cardinality. It's asking for how many are there. That would be 8. You can write it like that, or we could write it like this. It's both means the same thing. It's just asking how many elements are there in A union B. You would first probably want to find A union B. It makes the most sense to do this and write these out, or at least draw them on your Venn diagram. So you do that part first, and then go through and count them if you have a question that's asking for the cardinality or the size of the set. We'll have some more of those later. Just thought I'd introduce that now. The next one here is A complement intersect B. I'm going to show you a couple ways to do this one because I want to. First of all, A is everything inside the circle, which means A complement is everything outside the circle. So A complement would be 7, 9, 1, 3, and 5. Those are all outside of our circle. In other words, they are not A, right? So A, of course, would be A would be 10, 12, 4, 6, and 8. That's A. So not A is everything outside. Not A would be 7, 9, 5, 3, and 1. The next thing I'll do is I'll write out what B is. So B is all of this. B is 1, 2, 3, 4, and 5. The last part of this problem then is this sign right here is the intersection, which also means the overlap. It's also the and, remember? So the overlap, meaning the things that are in both of these two sets we just wrote out. And I actually think it's easier if we just zoom in on just this and we'll look for the overlap. Well, I can see that a 1 is in both of them. I see that a 3 is in both of them. And I also see that a 5 is in both of these sets. So my answer is 1, 3, and 5. A complement intersect B is 1, 3, 5. I actually think whenever you're doing complements and intersections, writing it out like this might be a little bit easier. Let's look at what that looks like on the Venn diagram though, and see that on the graph. So I'll start out by identifying a complement. Well, everything inside the circle is A, which means I'm going to color a complement. A complement is everything outside the circle. So a complement is all of this kind of peach coloring highlighter. So this is the first part of my answer set. That's a complement. The next thing that I'll do is I want to intersect that with B. So I'll come through and I'll highlight all of B. Anything that is colored purple here is in B. and I'm looking for the intersection of those, which means the things that are double colored. And at this point now, you can see that the double colored ones would be inside here. Hence, we end up with 1, 3, 5. If this were asking for the union, A complement union B, it would be anything that has any coloring on it at all. A union B would be 1, 3, 5, 2, 4, 7, 9. A complement union B. All right, let's move on. The last one, A union B complement. To start out with, I'll figure out what A union B is. A union B is anything in A along with anything in B. So anything that's circled right now is in the union. But because this wants not that, it wants the complement of those, it's almost like I want to get rid of them. Right? I can say, you know what? I don't want to see anything that's in here because it might confuse me. So if I want not that, I'll cover it all up. And the only things that I can still see are these ones right here, the 7 and the 9. So this one is just 7, 9. There. That's pretty much it for Venn diagrams. Everything else that we're going to do in the next section just makes them a little bit bigger. So let's go ahead and explore that. You can see here that we have a three-way Venn. A three-way Venn has A, B, and C, and it actually has 8 regions to it. If I were to number these, some people use Roman numerals. I'm going to just use regular numbers this time. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 different possible regions that something could be in. Now, a region for elements that are common to A, B, and C, that means the elements that belong to all 3 regions, A, B, and C, or all 3 subsets, I should say. That's number 5, right? That's this right here. That's the overlap of A, B, and C. The next one says we're looking for elements that are common to both A and B. Now, if it said just A and B, that would actually be both of these, this whole football shape. But it actually says something very important here, and it says A and B only. That means we want to exclude the elements that are also in C. So A and B only means A and B not C. So this is just 2. B and C only. Well, B and C would be this whole football shape, but we want to exclude this part here because that's also an A. So if we get rid of that, what we have left is this kind of chevron triangle shape. That's region 6 is common to B and C only. A and C only will be region 4. Elements that are A only is 1, B only is 3, C only is 7, and then 8 is the outside, the elements that have nothing in common with A, B, or C. Now, I did skip over this thing here at the beginning. When constructing a Venn diagram, start in the center and work outward. That's going to be more so whenever we don't have all of the elements and maybe we're going to be doing some subtracting. We'll get to that in a little bit. Let's fill these in. Again, there's several ways to do it, so whatever way makes the most sense to you. I think this time I'll go through and I'm going to start just with the elements that are in A this time. Again, if you want to start with the universe and identify every one of these where they go, do that. Okay, I know I'm doing it a slightly different way each time, but that's because I hope that at least one of these makes sense to you. I'm going to start with this P. Is P anywhere else? I don't see it in B and I don't see it in C. So I'll put it right there and then I'll cross it out. Next, I want to do Q. I don't see Q anywhere else. So I'll put my Q here and I'll cross it out. R. R is also in B And that's it. So I need A and B. So I'll put my R there, cross it out everywhere because I've used it. We're only going to write each of these letters one time. S. S is in all three of them, so I'll put S right here in the overlap, the intersection of all of them. Then I'll go down here to B, set B. A T occurs in both B and C, but not A. B, C, not A would be there. And I'll cross it out everywhere because I did it. U occurs in B and C, not A. Cross it out. V is only in C. Cross it out. And now everything else that I haven't put in A, B, or C just belongs in the universe. W and X both belong out there. Put these in however you want. There's multiple ways. I would encourage you to pause the video and go ahead and put your answers in here. Okay, in fact, I'm just going to put the answers up here in just a second. So pause, and in 3, 2, 1. Now's your last chance. Okay, here's the answers. So double check and make sure that you're right. Make sure that I'm right. If I'm not, make sure to let me know so I can get it fixed, because hopefully that's right, but I make mistakes too. The elements of each region are not listed. If the elements of each region are not listed, then you've got to subtract some of the regions. You'll see what I mean. You can only use the values that are specific to certain regions. So let's go to this first one. In a survey of 100 students, that's important, 78 of them were enrolled in math classes, 31 were enrolled in English classes, and we also had 4 were enrolled in neither. Now, hopefully you have something going off in your head saying, wait a minute, there's something wrong here. And hopefully you were right. Nope, I didn't write an incorrect question. The question is just fine. Let's go ahead and start to think about this though. 78 were enrolled in math classes. So if you come over here and write 78, we're okay for now. Don't write this in pen because we're going to do some erasing. 31 were enrolled in English classes. If I put 31 here, that's okay. 31 kids were in English. And then 4 were enrolled in neither. So we know that that goes way out here. But if we take a minute now and we add these up, I have 78, 31, and 4. 113. It seems like I have 113 people. Well, the problem is I only had 100 people, but I have 113 on my diagram. That means I have 13 too many. Well, it seems then that I have double counted 13 people. If I have 13 people too many, it's because I double counted them. The double counted people actually belong here in the middle. So what I'll do is put a 13 here, and I'm going to subtract 13 from each of these other ones. Now, when I look at the Venn diagram that I have left, I can check to make sure that all my numbers kind of make sense. For example, do I have 78 students signed up for math, like this says here? Yeah, 65 and 13. Sure, there's 65 students that are signed up for only math, and there's 13 students signed up for English and math. Combined, there are 78 students enrolled in math class. So that seems good. Let's go to the English class. There were 31 students enrolled in English class. If I look at all of my English class students and I add 13 and 18, yes, there's 31. And I can do one more thing, and that is to check to make sure that I have a total of 100 students now. If I add 65, 13, 18, and 4, I do get 100 students. So it seems like my Venn diagram has now been fixed. Okay. We should ask ourselves, have we answered the question? We actually didn't. We made a nice Venn diagram. Boy, we sure did a lot of work. But you know what? We still have to answer the question. See, the question here, how many students are enrolled in both classes? That's this part right here. So we want to make sure that we indicate we know what the answer is. 13 students were enrolled in both. That's our answer. Keep in mind that a lot of times when you have a word problem, your answer should probably have words in it. It's very rare that you're going to have a word problem and all you have is just a random number. So just saying 13, okay, but these are 13 students that were enrolled in both math and English classes. Let's go to the next one. 120 people were asked if they liked mint or cinnamon toothpaste. 74 people like mint, 35 people like both, 19 liked neither. How many people like only one of the flavors? This is a case where earlier in the lesson I said that you should start in the middle when you have a both kind of scenario, or when you're trying to fill the numbers in, we should start in the middle. This is where that applies to. So it says that 35 people liked both. I'll put 35 here in the middle. Now when I start going backwards, I see 74 people like mint. This whole circle here needs to have 74 people total. And if I want to have 74 total in that circle, and I already have 35, what I'll do is take 74 minus 35 and get 39, I hope. Notice now that there are 74 people in the mint circle. Should be good. The next thing I'll do is 19 people liked neither, so I'll put 19 on the outside. I only have one section left to figure out, and that's this part right here, the people that like cinnamon exclusively. I do know that I should have 120 people, so if I add together 39, 35, and 19, I think I get 93. And then I know that I had 120, so I'll do 120 minus 93 and get 27. So 27 belongs here in this red spot. Now I need to actually answer the question. The question says, how many people like only one of the flavors? Well, these 39 people here only like mint, and these 27 people here only like cinnamon. So if I add together 39 and 27, then that will get me 66. There are 66 people who only like one flavor. All right, this is the last one of these. A recent study on couch potatoes found that upon sitting down, by the way, I had a student ask me, what's a couch potato? I've never heard of that before, which was surprising to me, but let's just be clear. Maybe not everyone uses this term. A couch potato is someone who might be deemed a little bit lazy, someone who just goes down and sits down on the couch and just wants to watch TV, or sit down on the couch and not do anything. We might call them couch potatoes. A couch potato found that upon sitting, a recent study on couch potatoes found that sitting down, 70% will turn on the TV, 60% will take out their phone, and 45% will do both. This is another situation where we need to make a Venn diagram, so I'll start out by making a rectangle, followed by two circles. I'm so good at drawing circles. And then we can start to put in our numbers. So I'll label this one TV and I'll label this one phone so that I know which is which. I see that 45% will do both. That's where I'm going to start. I'll start by writing 45 in the middle. Next, I see it says 60% take out their phone. So this whole circle needs a total of 60, but I already have 45. So if I do 60 minus 45, that tells me that I need to add in a 15 right here. On the other side, for TV, I know that it needs 70 total. 70 people will turn on the TV, 70%. And I already have 45. So if I subtract off the 45 that I already have, that gets me 25 more. So we'll put our 25 out here. Now, if I look at what I have 25, 45, and 15. If I add all those up, I get 85%, and a percent's out of 100, so I'll go ahead and subtract that to get the rest. This would be the part that's out here in the universe. This would be 15%. The question actually just says, create a Venn diagram for this information, and we have. We've created a very clear Venn diagram. Whoops. And we're done. That's it. So let's make sure we do understand what our Venn diagram is saying, though. This 45% here are people who would watch TV and play on their phone when they sit down onto the couch. These 25% here are people who would sit down on the couch and they would just watch TV. They might focus on the TV. They don't do this whole second screen thing. These 15% here in this circle would sit down on the couch and they would not turn the TV on. They would just pull out their phone and have a little quiet time on the couch with just their phone, no TV involved. Lastly, these 15 people out here in the universe, or this 15% out here, these are people that would sit down on the couch and they wouldn't pull out their phone and they don't watch TV either. So maybe they're going to sit down and read a book. Maybe they sit down and take a nap. Maybe they sit down and grab a bag of chips and just have some quiet time, whatever it may be. But it is important to understand the context of what each of these regions is portraying. Next, we have a group of 45 college students who are asked what type of foods they most often eat late at night. The options are pizza, tacos, and burgers. Let's go ahead and we'll try to fill this in. Remember, we should start in the middle. I'm going to start with this one here in the middle. Also going to use blue because I think I prefer that. 3 people ate all types of food. That's where I want to start. Next, 7 people ate tacos and hamburgers. Tacos and hamburgers would be this whole section here, this football-shaped section. There should be 7 there, but I already have 3, so I'll do 7 minus 3 and realize that 4 need to go there. Now I have a total of 7 people in the taco burger intersection, and 3 of them also ate pizza. Okay. Next, we've got to figure out, there were 5 people that raised their hand and checked the box, hey, I eat pizza and burgers. So 5 people belong in this football shape, but 3 of them were already counted. That means I need 2 more. There were exactly 2 people who said I eat pizza and burgers, but not tacos. We'll keep working our way up. We'll do this one next. 6 people said yes to pizza and tacos. So the whole football needs 6, and I already have 3. That means I need 3 more. Now there's 6 in that football. 20 people ate burgers, so this whole circle needs 20 people. Notice that I already have 9 people included in this. There's 9 people already in that burger circle. So that means I need 11 more. I'll just put an 11 there, and now I'm good. We need 17 people ate tacos. So the whole taco circle should have 17, but I already have 10 in there. So I'll do 17 minus 10 means I need 7 more. There were 7 people who said, I eat tacos exclusively. I only eat tacos late at night. Lastly, we're going to do this 19 pizza people. This whole big circle here needs 19, and you can see I already have 8. There are 8 people in the pizza circle already. So 19 minus 8 is 11. Now, it may seem like I'm done, but I'm not. Let's double check something here. If I add up all of these numbers, 11 plus 3 plus 7 plus 2 plus 3 plus 4 plus 11. Okay, so let's take a minute and do this. Well, this is 10, and this is 9. So now I have, let's see here, 20 and 21 makes 41. That's how you can tell I don't have a calculator, so hopefully I'm right. Sounds good. This is only 41 people though, but notice back up here it says a group of 45 students were asked. Where are the other 4 students? Well, the other 4 students, right, 45 minus 41, the other 4 students belong out here in the universe. There were 4 students that did not check the box for pizza, tacos, or burgers. Okay, there. Now we have all 45 people accounted for. Let's next move down and answer some of the questions about this. How many ate exactly one type of food? Well, these people out here ate exactly one type of food. They liked pizza. These 11 people only liked burgers, and these 7 people here only liked tacos. So what we'll do is we'll add together 11 plus 11 plus 7, and that should be 29. How many ate none of the 3 options? Well, that's just these 4 people here. There were 4 individuals that did not like any of these options. How many ate pizza or tacos? Well, notice this or, that's a union. And also notice that it doesn't say anything at all about burgers. It just wants to know pizza or tacos. You could almost think of this as pizza union tacos. So the union will be anything that's in pizza along with anybody that's in tacos. There. All those people ate pizza or tacos. Now, I can do this a couple ways. Watch. I could add together all these numbers and say 11 plus 3 plus 7 plus 2 plus 3 plus 4. Okay, that's 21. And then 5 and 4 makes 9. That's 30. Okay, my answer for this is 30. But you know, I probably could have gotten this a little bit quicker. Just consider this. If I want all of this, then really, I just don't want this one and this one. Those are the only 2 numbers that I don't want. I can add those up really easy. There's 15. There's 15 people that I don't want out of these 45. That's another way that you could get 30. So those of you that are like, man, when am I ever going to use the complement? Well, sometimes it's just faster. That was way easier for me. All right, how many people ate both tacos and pizza? So that's an that's an intersection or the overlap. And so if we want tacos and pizza, that would be all of them. So both tacos and pizza would be 6. How many ate at least 2 of the food options? All right. This is where we got to make sure we understand what the question's asking. So, did these people eat at least 2 options? No, they only ate pizza. Did these people? Yeah, they liked pizza and tacos. What about these people? Nope. Those 7 only ate tacos. That's just one of the options. That's not at least 2. These people ate pizza and burgers. These people ate all 3 options. These people ate 2 options. So those ones there in the middle are the ones that ate at least 2 of the food options. And so that's going to be 3 plus 3 plus 2 plus 4. That should get us 12. Lastly, ate pizza and burgers but not tacos. So pizza and burgers, if I start out with that, that would look like these 5. 5 people ate pizza and burgers. And then it comes through and it says, but not tacos. So that means we want to get rid of those taco people like that. The only ones that's left are those 2. So our answer to this one is just 2. 2 people ate pizza and burgers, but not tacos. Ooh, that's a lot. All right, last one. A survey of 500 people asked which coffee brewing methods they regularly use at home. The options were press, like a French press, K-cups, and drip coffee makers. The following were recorded. So I'm going to scan down here, and the first thing that I notice is 60 people used none of the 3. What? Okay. You know what? Great. I actually looked right past the most important one as well, and that was 30 people used all 3. So I'm going to start there. There. That one's probably a little bit easier for me to start with. It's where I should start with, the one with all 3. Next, 120 used press and drip. So press and drip would be this football shape. That's 120, and I already have 30. So if I subtract those, you can see I need 90 more. 90 people belong in that section right there. Next, we're going to look at 85 used K-cups and drip. So drip and K-cups would be this football. And we want a total of 85, and I've already got 30. So we'll subtract those and find that 55 belong right there in the K-cup and drip, but not press. Next, we have 95 people used press and K-cups. So press and K-cups is that overlap. Press and K-cups should have 95 people total, but I've already got 30. So if I subtract those 30, that's how I can figure out that 65 people belong right there. Next, it tells me that 260 people used press coffee. So my whole press circle should have 260 in it. If we add what we have so far, we're going to add 90, 90, 30, and 65. That's 185 people. I've already got 185 people, but I need 260. So we'll take 260 minus 185 and hopefully get, nope, not 85. How about 75? Yeah, that sounds right. That's how we know that there's 75 people that belong there in the press section. We're almost finished. Boy, there's a lot going on here. 210 used K-cups. So we'll look over at the K-cup section, which is here. There should be 210 people in that spot. And if I add up the ones that I have, I have 150, but I need 210. So I'll take 210 minus 150 gets me 60. So there's 60 people out here. Okay, you can see hopefully there's only one more spot that we don't have. This spot right here. I don't have anything for that. Now, sometimes things are just blank. It could be that that's 0. I don't know, but I can figure it out because what I've got to do now is add up all the numbers that I have and see if they add up to be 500 people. So let's start adding these up. Now, I also want to tell you another thing. Some people will just go through and they'll do 75, 65, 30, 90, 60, and 55. And that's fine. Like they just add them all up, add up all 6 of those, and you're good. You have a calculator, easy peasy. But did you notice that here, all 4 of those together, haven't I already done that? I, I mean, don't I know that there's 260 people that use press coffee? And so if I add those up, I should hopefully get 260. Like if I mathed correctly, that should be 260. And maybe I grabbed a calculator just to double check that real fast. By the way, I also noticed that I forgot to add this 60 on down here. So now, if I just add everything that we still have, if I add all 260 of those, plus the 60, plus the 55, plus the 60, if I add those all together, I get 435. But keep in mind, there should be 500 people. And that's how I figured out how many people there are in the drip. So we'll do 500 minus 435 is 65. The last thing is to actually answer the question, how many of the people surveyed used exactly one brewing method? Let's identify those 3 regions that we're looking for. These 75 people only use press coffee. These 65 people only like drip coffee. And these 60 people out here only like K-cups. So what we'll do is we'll add together 75 plus 65 plus 60. They think that's 200. 30, 140, 200. Sounds pretty good. All right. Boy, that's a lot. That's a long lesson on Venn diagrams. I hope this helps. I would strongly encourage you to go back and redo some of these on your own, where you pause the video and just make sure that you can work ahead and that these make sense to you. All right, good luck as you practice your Venns.